Welcome back to today's videos class. In the last video class we have completed our chapter number 13. Okay, so in today's video we will start chapter number 6 is 16, symmetry. Then what is called, it is reflection and rotation. First of all, we should know the definitions of these all three things, that is symmetry, reflection and rotation. What is symmetry? Symmetric means the identical figures. If you divide a figure into two identical figures whose length, breadth, size, each and every coincides with one another, the figures are said to be symmetric figure. Suppose if you take your two palms, if you match them, they are symmetric to each other. When you go and stand in front of mirror, your image and you are symmetric to each other. So these are called symmetric figures. Reflection, we have read in your physics that the bouncing back of light is called reflection. So reflected images are also are symmetric to each other. Next, then rotational figure. Rotational figure means if you rotate the figure will not change its dimensions or its angles. Then they are called as rotational figure. We will see by example what are rotational, what are symmetric and what are reflected figures. Okay, so in this regard, first of all we will do that is the linear symmetry. We will do linear symmetry. What are linear symmetry? Linear symmetry means any figure that has only one line of symmetry of it. Suppose if I draw a arrow like this, how many symmetric line you can draw of it? Only one. Only one symmetric line can be drawn like this. So this is a symmetric figure. If you take a triangle like this, here also you can draw one symmetric line. So this is a symmetric figure and these dotted lines are called line of symmetry. Okay, sometimes few figures are having more than one symmetric lines. Suppose if you take a square, like this, you are having with four line of symmetries, one vertical, one horizontal and the two diagonals. Okay, so there are so many line of symmetry of this square, and the point at which these symmetric lines coincide with each other, this point O is called point of symmetry, point of symmetry. So the different figures have different number of line of symmetry, and if the line of symmetry are more than one, the point of intersection of line of symmetries are called point of symmetry. Okay, so the point of exists in a figure that's built around a single point around its center of the figure. Suppose a circle is having the center of the circle. If you take a circle, so this center is the point of symmetry, because from this point you can pass infinite number of symmetric lines, because circle is having infinite line of symmetries. You can see lots of symmetric lines you can draw like this. So again this point is called point of symmetry. Next point is the reflection. You know what is reflection? Reflection. What is reflection? So by the definition, when you stand in front of a mirror, your image is formed in the mirror. That is called reflected figure. So this is called reflected figure. Suppose if you take a line and draw a perpendicular bisector of this line. So half of this line, suppose it is AOB. If OA equals to OB, then these two figures are called as reflected figures like this. So the perpendicular bisector of a line segment is a line of symmetry also, and the two parts of the lines which are divided by the perpendicular bisector also form a reflected figure. Okay. So you can have so many reflections and symmetric figure with each other. So after this, next point is the rotation. Next point is the rotational figure. Rotation. What a rotational figure? Rotational figure means if we turn a figure by some angle and the figure does not changes, then it is called rotational figure. And the angle through which the line figure is rotated is called angle of rotation. And a figure can be rotated in so many number of times that are called order of rotational symmetry. We call them as order of rotational symmetry. So what is rotational symmetry? Rotation. So if you take a triangle like this, okay. Now if you want, this is an angle, but if you want to rotate by this angle, so you will get another triangle of like this. So it is rotated in this angle. Okay, it is rotated in this angle. If you rotate it in the angle of 90 degree, suppose in the angle of 90 degree, that means it is the angle of, so this is 90 degree is called, it's the angle of rotation. This is called angle of rotation. Okay. So angle of rotation of this is 390 degree. If you rotate, that means you can make it 4 times. Another like this. You can rotate here also like this. Another rotational. After that, one rotation you can make another like this. So that means if you rotate this angle in angle of 90 degree, that means you can rotate this figure 4 times. So number of rotation is here. Number of rotation is 4. Why it is 4? Because we are rotating this triangle by the angle of 90 degree and complete angle is 360. So 90 into 4 is 360. That means you can rotate this in this angle. You can rotate this triangle in 4 times. So number of rotation is, so number of rotation is 4 here. Okay, and the angle of rotation is 90 degree. Next is the order of rotation, order of rotational symmetry. If you take the angle which you are taking, in that order the figure will be rotated. So order of rotation is 360 by angle of rotation. That is also called order of rotation. Next point is line of symmetry and rotational symmetry. The same thing we have seen. Now we will see some special figures that have the lines of symmetry. Suppose it is given in your book. You can see a line segment has only one line of symmetry, that is the perpendicular bisector that I have shown you also. On one point of symmetry, the midpoint of the line segment, and it is rotational in order of 180 degree because angle of rotation is 180 degree. So you can rotate only 2 times. Okay, then 180 plus 180 is 360. So you can rotate it only 1 times. Then angle, it has only one line of symmetry, no point of symmetry, and it is not rotational also. Scaling triangle, no line of symmetry, not rotational, no point of symmetry. Isosceles triangle, only one line of symmetry and no point of symmetry, because only one line of symmetry line cannot have a point of symmetry, and it is also not rotational. Equilateral triangle, 3 lines of symmetry and no point of symmetry here. The rotational symmetry is order of 3. So center of rotation, point of intersection of the angle bisectors are called point of symmetry. Parallelogram, no line of symmetry, one point of symmetry, that is the intersection of diagonals, and it is rotational also of order 2. Isosceles trapezium, no line of symmetry, one line of symmetry only, no point of symmetry, and it is also not rotational symmetry. Rectangle, 2 lines of symmetry, 1 point of symmetry, means the diagonals or the horizontal and perpendicular bisector of 2 sides, they intersect at points, so they are 2 points of line of symmetry, and the diagonals are only point of symmetry, and it is rotational of order 2. Rhombus, 2 lines of symmetry is having 1 point of symmetry, and it is rotational or also rotational of order 2. Square, I have shown you, it has 4 lines of symmetry, it is rotational also, it has 1 point of symmetry and rotational of order 4. Kite, only 1 line of symmetry, no point of symmetry, it is not rotational also, so it having no order of rotation. Arrowhead, it also having only 1 line of symmetry, no point of symmetry, it is not rotational symmetry. Semicircle, only 1 line of symmetry, that makes divide the semicircle into 2 quadrants. The perpendicular bisector of the diameter, no point of symmetry, it is not rotational also. Regular pentagon, it is having 5 line of symmetries, point of symmetry is none, and the order of symmetry is, it is rotational also, so its order is 5, but it should be regular pentagon, means all pentagons whose all sides are equal. Regular hexagon means 6-sided figure whose all sides are equal, all 6 sides, so it having 6 line of symmetry, 1 point of symmetry, and it is also rotational of order 6. Circle, it's infinite number of line of symmetry, center is the point of symmetry, and it is rotational also, but infinite order. So some English alphabets are also symmetric, like A, B, C, D, E, H, I, M, O, T, U, V, W, X and Y are symmetric letters. But rotational symmetric figure are H, I, N, O, S, X and Z, they are rotational. So this is all about your theory part of the chapter. Now we will see few questions in your exercise, that is exercise number 16. We will see exercise number 16 now. It's only one exercise, only 4 questions are there. The first question is that draw the line of symmetry, if any, for the following shapes. Okay, so first number 1 is the figure is like this. 2 circles are there, one smaller and bigger. So how many line of symmetry can you draw? So here only 1 line of symmetry can be drawn, which passes through the line joining the center of the circles. Only 1 line of symmetry we can draw. Okay. Similar figures are there in question 2, also 1 symmetric figure, 1 line of symmetry. In number 3, the ball figure, number 3, is like this drawn. So if you draw a figure this symmetric, it is not, you cannot make a symmetric figure. So none of the symmetric line can be drawn through this figure. The plus sign, it has a 4 line of symmetry like this. You can see the figure. Okay, so you can draw one this way, line of symmetry. You can draw this way, one line of symmetry. Or diagonally you can draw a line of symmetry. So there are 4 line of symmetries. Now, which of these are rotational? It is not rotational, but it is rotational figure. Also in question number 2 it is asked rotational symmetry or not. It is rotational symmetry of order, this will be rotational of order 4. Now question number 3 it is asked construct a rectangle whose sides are given, adjacent sides, and draw, you have to draw the line of symmetry. So 2 sides are given, how you have to draw the figure? AB, BC is 4.5 and 3 centimeter. Question number 3. So first you draw the base, that is 4.5 centimeter. Name it as AB, A and B. Draw 290 degrees on these points like this. So it is a way of drawing a rectangle. Now the adjacent, another adjacent is 3 centimeters. So from here you take a radius of 3 centimeter compass, you cut the arc. From here also you cut the arc and you join them. So this is ABCD is a rectangle you will get. And now you have to draw the line of symmetry. So it has 2 lines of symmetry, that one is the vertical and another is the horizontal. So these are the 2 line of symmetry. The next question is construct a rhombus whose ABCD is AB is 5.3 centimeter and angle A is 60 degree. Now you have to draw the line of symmetry. So by the definition of rhombus, you know that all sides of rhombus are equal. So if one AB is 5.3 centimeter given, that means all the 4 sides are also 5.3 centimeter. So first of all you draw the rhombus. How will you draw it? First you have to draw a line that is of 5.3 centimeter. Take it as A and B. So angle A is given 60 degrees. So at point A you have to draw 60 degrees. Suppose this is the okay. Now here what you have to draw? If it is AB is 5.3, then AD is also 5.3. So make arc cut 5.3. From B also cut 5.3. From A, D also 5.3. So now you join them. You will get a rhombus ABCD. Now you have to draw the line of symmetry. So the 2 diagonals are its line of symmetry. Okay. So this is the point of symmetry also. So in this way you have to draw the figure, and you have to learn the number of rotational symmetric lines, point of rotation, and number of rotations, point of symmetry from the description that is given in your book. Go through the book and solve these questions. Okay students, hope you have understood this chapter very well. Thank you very much for watching this video. If you get any doubts, do ask me in your next online class. Thank you very much. Goodbye.